Hello, and today we're going to start on the first lesson in the Unit 3, Systems of Inequalities. And Lesson 1 is Introduction to Inequalities. So let's begin by looking at the definition of an inequality. An inequality is an expression that has a greater than or less than sign. Those are these right here. As you can see, there are 4 of them. So let's look at the first one. The first one is less than. All right, and the second one is greater than. And the third one is less than or equal to. And the fourth one is greater than or equal to. All right, well, what makes these greater than or less than or equal to? The equal to part is right here. If you look on both of them, you see that line underneath. Those determine the equal to part. And if you see up top, it's lacking that line on both of those, hence why they don't have the equal to part. All right, so let's move on with some very simple examples, like the first one here, 3 less than 5. 3 is less than 5. Okay, that's a true statement. Mathematically speaking, it's a true statement. There's the next one here is 15 is greater than or equal to x. And how you write that is 15 greater than or equal to symbol an x. This is also the same as x is less than or equal to 15. Think about it. If 15 is greater than x, then x must be less than 15, so it's less than or equal to 15. These two are the same. They mean the same. Okay? All right, let's move on. So representation on a number line. When x is greater than a certain number, we're going to shade to the right. And when x is less than a certain number, we're going to shade to the left. Okay, that's pretty intuitive there, I hope. And let's continue on. So the difference between an equal to and not. So when a particular inequality is greater than or equal to, the circle we make on our number line will be filled in. So I'm just going to write filled in, and then I'll show you an example. For example, if that's the point we're talking about here, it's going to be a filled in dot. Okay? Oops, did not mean to click on that. When a particular inequality is just greater than the circle we make on our number line, will be not filled in. So for example, not filled in. Can't write. Notability is so awesome. We love it. So here's an example of not filled in. You're going to see it that way. And then the same goes for the less than or equal to versus the less than. So obviously we're going to shade these two. It could be a shading of this way or this way. Similarly here, it could be this way, which would be greater than, or this way for less than. So that depends on the specific expression that we're talking about or the equation that we're talking about. All right, let's move on with some examples. So we want to be able to express each thing that you see on the left column on the number line, that's in the middle column here, and we want to be able to write down how you pronounce it. So we're going to start with the first one, okay? Let me switch back to my black color. Okay, so number line, draw a number line, arrows on both ends, because the number line continues in both directions. That's my 5. Okay, and because it's this here, right here, do you see that line underneath? It's equal to, so therefore, this particular dot needs to be filled in. So it's less than or equal to. All right, and because it's less than, it's to the left shading, and then you're done. All right, so let's do this again, but this time for this one here, 8 less than x. So x is greater than 8. Either way, you can represent that, whichever one helps you see. All right, so here's our number line. And let's write 8. And it's going to be greater than, so definitely not a filled in hole, not greater than or equal to. The point is hollow. And we're going to shade to the right because it's greater than. And then we're going to fill out how to say this in words on the last column here. So you can, we'll just stick to the original statement, the original expression. 8 is less than x. That was this example that we just did. And let's do the last one. X is less than 7. So let's represent that here in the first column by writing x is less than 7. All right, draw your number line and label your 7. And it's less than, and it's not equal to, so just less than. Don't fill in the dot. And because it's less than, you're going to shade to the left. All right, let's continue on. Solving inequalities. So in order to solve an inequality, we must get the variable by itself. Sounds like what we've been doing even with equalities in the past, doesn't it? We're going to isolate the variable. Okay, so but we use the skills that we already possess from solving equations. So it's nothing new here, definitely nothing new here. What will be different is between the equations and inequalities is that there's going to be shading happening to the left, to the right. If it's less than or equal to, there's going to be the point will be filled in as opposed to just less than. It won't be. Examples like that. So we're going to actually look at some situations that there is a specific situation where we have to be very careful about. It's called a special case that we're looking at here. And dividing by a negative number, the inequality symbol switches sides. So what do we mean by that? So let's do this particular example and I'll show you what I mean by that. So example is negative 2x is less than 6. Okay, so what would we do if that was an equals? Okay, well, we want to get rid of a negative 2 that's being multiplied to x. So we're going to do the opposite by dividing by a negative 2. Well, when you divide both sides by negative 2, x is left on the left side. And on the right side, it's negative 3. Okay, it's very important that you see here that since we're dividing by a negative number, this symbol switches. Okay, and it doesn't switch because the answer is negative 3. It switches because we're dividing by a negative 2. So here's just real quick another example. If it was like this, and we divided by negative 2 just like we did before, and x. This would be 3 here, but it would still switch sides, so it is not dependent on the 3 being positive or negative. It's dependent on this number here, what you're dividing by. Let's change that color so it pops out right here for you. That's what tells you that you are dividing by a negative, and hence the symbol changes. Okay. Let me get rid of some of that arrows so that you don't go what later. What is she pointing to here? All right, so let's move on. Solving graph on the number line. So these are the type of questions that you're going to see more frequently. Well, so let's start doing this. So we have variables on both sides, right? So we are isolating the variables, but before we can do that, we have to combine all the variables to one side. So 5t minus 6 greater than or equal to 4. All right, then add your 6. 5t greater than or equal to 10. And then finally divide by 5. So it's t greater than or equal to 2. That's your answer. And let's represent that on a number line. Greater than or equal to 2. So I'm going to shade to the right. That's why I put my number a little bit closer to the left, just so I have space. And it's equal to. So let's make sure we add that to our picture here. It is a filled in dot. And then you're going to shade to greater than, so to the right. All right, let's do another example. We're going to solve and graph this on a number line. Well, as always, we don't like parentheses because we can't really touch that 2 and the -1 inside of that parentheses, that -1. So let's distribute that 8 first. 8. Distribute it to both, so we have 16w minus 8 is less than 8. All right, so let's continue solving. Add 8 to both sides, and we have 16w is less than 16. And keep going, divide by 16, so w is less than 1. That's your answer, and let's graph that on the number line. It's less than 1, so we're going to shade to the left. So I'm going to put my 1 right here, closer to the right, so that I can have space. And because it is less than and not less than or equal to, make sure your point is not filled in. And then finally, shade to the left, like that. And here's the last problem. So let's start again. Okay, well, let's start with subtracting our 3's. And it's -2y less than or equal to -12. Okay, get rid of the -2 by dividing and divide both sides. All right, so y, I'm going to do this a different color, greater than or equal to +6. Okay, just a really quick reminder, that is why it switches. Okay, because you just divided by that negative, so it is greater than or equal to. Okay, that's our answer, and let's graph it. Here's 6. It's greater than or equal to, so fill in that hole in the point. Don't make it hollow. It's a filled in point. Okay, and highlight or shade, make it darker on your paper as long as it's visible. If you don't use a highlighter, that's okay. As long as you're visibly showing that it's darker to the right, it's all good. So greater than or equal to 6. Well, I hope you